SSL certificates don't exist in isolation. They're part of a system called Public Key Infrastructure, PKI. Understanding PKI explains why certificates work, what their limitations are, and why certificate errors happen. PKI is built on asymmetric cryptography. In asymmetric cryptography, you have a key pair, a public key and a private key. They're mathematically related but not identical. What you encrypt with one key can only be decrypted with the other. If you encrypt something with the public key, only the private key can decrypt it. If you sign something with the private key, anyone with the public key can verify the signature. In TLS, a server has a key pair. The public key is in the certificate and shared with everyone. The private key is kept secret on the server. If it's compromised, your certificate is compromised. The certificate authority uses PKI in a specific way. The CA has its own key pair. The CA uses its private key to sign your certificate. Anyone who has the CA's public key, which is in the browser's trust store, can verify that signature. Verified signature equals legitimate certificate. The chain of trust, your server certificate is signed by an intermediate CA. The intermediate CA's certificate is signed by a root CA. The root CA's certificate is self-signed, it vouches for itself. Browsers trust root CAs because they've been pre-installed in the browser or OS trust store. This hierarchy exists for security. Root CA private keys are kept in extremely secure hardware, rarely used. If a root CA key were compromised, all certificates in the entire trust hierarchy would need to be revoked. Intermediate CAs sign day-to-day certificates, limiting the blast radius of any compromise. When you get an SSL certificate, you receive multiple files. The naming and content can be confusing. Let's clarify what each file is. The certificate file contains your server's public certificate in PM format, base64 encoded, begins with begin certificate. This is what you give to Nginx. It identifies your server to clients. The private key file contains your private key, begins with begin private key or begin RSA private key. This never leaves your server. Nginx uses this to decrypt traffic and sign messages. If someone steals this file, they can impersonate your server. The certificate chain or full chain includes your certificate plus all intermediate CA certificates. Browsers verify the full chain up to a trusted root CA. If you only provide your certificate without the intermediates, some browsers will reject it. They can't complete the chain of trust. Always use fullchain.pem with Nginx. When Let's Encrypt issues a certificate, it gives you 4 files in /etc/let's encrypt /live /yourdomain /cert.pem, your domain's certificate only, without chain. Chain.pem, the intermediate CA certificates, without your cert. Fullchain.pem, your cert plus chain combined. This is what Nginx uses as SSL_certificate. Privkey.pem, your private key. This is what Nginx uses as SSL_certificate_key. The correct Nginx configuration uses fullchain.pem for SSL_certificate and privkey.pem for SSL_certificate_key. Using cert.pem instead of fullchain.pem is a common mistake that causes intermittent SSL errors on some browsers and mobile devices. Before issuing a certificate authority must verify that you actually control the domain you're requesting a certificate for. This process is called domain validation, DV. CAs have 3 standard methods for domain validation, defined in the CA/browser forum baseline requirements. Method 1, HTTP01 challenge. The CA gives you a random token and tells you to put it at http://yourdomain.com/.well-known/acme-challenge/token. The CA then makes an HTTP request to verify it's there. This proves you control the web server at that domain. Limitation: doesn't work if you're behind a load balancer without shared storage, doesn't work for wildcard certificates. Method 2, DNS01 challenge. The CA gives you a random token and tells you to create a TXT record at _acme-challenge.yourdomain.com with that value. The CA then queries DNS to verify it's there. This proves you control the DNS for that domain. Works for wildcards, star.yourdomain.com. Works even if your server is behind a firewall. The disadvantage: you need API access to your DNS provider for automation. Method 3, TLS ALPN01 challenge, validates using a special TLS extension on port 443. Less common, used in specific automated scenarios. Let's Encrypt uses ACME, Automated Certificate Management Environment, protocol and open standard for automating these challenges. CertBot is a client that implements ACME, handling the challenge creation, verification, and certificate issuance automatically. Organization validation, OV, and extended validation, EV, certificates require additional verification beyond domain ownership, verifying the organization's legal existence through business registries, phone verification, etc. DV certificates, what lets Encrypt issues, only verify domain control. All SSL certificates have a finite validity period. After the expiry date, browsers will show a security error and refuse to connect to your server. Certificate expiry is one of the most common causes of production outages. Historical context, certificates used to be valid for 2 to 3 years. Over time, maximum validity has been reduced. Today, publicly trusted certificates have a maximum validity of 398 days, about 13 months. Let's Encrypt issues 90-day certificates. While Let's Encrypt uses 90-day certificates, shorter certificates reduce the window during which a compromised certificate can be misused. They also encourage automation. You need to renew frequently, so you're forced to automate. If certificate renewal is automated, a 90-day expiry is no less convenient than a 1-year certificate. Renewal timing, CertBot's recommendation is to renew when there are less than 30 days left. Let's Encrypt even allows renewal when 60 days or less remain. Never wait until the last day. Automated renewals can fail, and you need buffer time to notice and fix the issue. How to automate renewal? CertBot installs a systemd timer or cron job during installation. The timer runs twice daily. CertBot renew. This command checks all your certificates, and if any will expire within 30 days, it renews them automatically. You don't need to do anything manually for renewal after initial setup. Renewal failure scenarios, your web server isn't running, HTTP 01 challenge fails, your DNS record is wrong or removed, DNS 01 challenge fails, your API key for DNS automation is revoked. Set up monitoring to alert on certificate expiry, tools like checksSL.com or Prometheus with the SSL_expiry metric. Understanding certificate errors helps you diagnose both your own setup and identify genuine security issues. net_error_cert_authority_invalid. The certificate was issued by an authority that the browser doesn't trust. Causes: you're using a self-signed certificate, you're using a certificate from a private CA not in the browser's trust store, or the certificate chain is incomplete, missing intermediate CA. net_error_cert_common_name_invalid. The domain in the certificate doesn't match the domain you're visiting. Causes: you're visiting emyap.com but the certificate is for www.emyap.com, need to include both in the certificate. The certificate expired and was replaced with one covering different domains. You misconfigured Nginx to use the wrong certificate for this server block. net_error_cert_date_invalid. The certificate is expired or not yet valid. Causes: certificate expired, renewal failed, server time is wrong, the not before check fails because the server clock is behind, you're using an old certificate that hasn't been replaced. ERR_SSL_protocol_error, TLS version mismatch or cipher suite negotiation failure. Causes: the server only supports TLS 1.0/1.1, deprecated, a firewall or security appliance is intercepting the TLS connection. Self-signed certificate errors: during development, self-signed certificates cause browser warnings. Using Encrypt for local development creates locally trusted certificates without warnings on your machine. In production, always use CA-signed certificates. curl insecure: in curl, K or insecure bypasses certificate verification. Never use this in production scripts, it defeats the purpose of HTTPS. It's acceptable for quick debugging of self-signed certificates in development. Certificate Transparency, CT, is a public logging system for SSL certificates. Every publicly trusted certificate must be logged in at least 2 CT logs. Browsers verify this as part of certificate validation. Why CT exists: in 2011, an attacker compromised the DigiCert CA and issued fraudulent certificates for domains including google.com, gmail.com, and others. These certificates were used in man-in-the-middle attacks against Iranian users. CT was designed to make such fraudulent issuance detectable. How CT works: when a CA issues a certificate, it submits it to one or more CT logs, append-only, publicly auditable logs. Each log entry is verifiable. The certificate includes signed certificate timestamps, SCTs, from the logs. Browsers check for valid SCTs before trusting a certificate. What this means for you: every certificate your CA issues is publicly logged. You can search for all certificates issued for your domain at crt.sh. This is both a transparency mechanism, you can see all certs ever issued for your domain, and a security tool, you can detect if someone illegitimately obtained a certificate for your domain. Checking your domain's certificates: go to crt.sh and search for yourdomain.com. You'll see every certificate ever issued for that domain, including the issuance date, expiry, CA, and SANs. CAA records. You can restrict which CAs are allowed to issue certificates for your domain using DNS CAA records. If you only want Let's Encrypt to issue certificates for emyap.com, add a CAA record, 0issue let'sencrypt.org. If a different CA receives a request to issue a certificate for emyap.com, the CAA record tells them to refuse. The private key is the most sensitive file on your server. If it's stolen, an attacker can impersonate your server. They can present your certificate and decrypt traffic meant for you. File permissions. The private key file should be readable only by root, or the user running Jinx. Jinx reads it at startup with elevated privileges, sudo chown root etc let'sencrypt live myapp.com privkey.pem and sudo chmod 600 etc let'sencrypt live myapp.com privkey.pem. Let's Encrypt sets these permissions automatically. Never put the private key in version control. The certificate, fullchain.pem, is public. It's fine to log and share. The private key must never be committed to Git, stored in environment variables that are logged, or shared with anyone. Backup private keys. If you lose your private key, you need to generate a new one and reissue your certificate. Certbot can reissue a certificate with Certbot Certainly Force Renewal, but the old certificate is no longer usable. Keep an encrypted backup. Passphrase on private keys. You can encrypt private keys with a passphrase. However, Jinx needs the passphrase to start, which means you'd need to enter it manually on every server restart. For automated production use, unencrypted private keys stored with strict file permissions are the standard approach. Key rotation. When should you get a new key pair? If you suspect the private key was compromised, file permissions were wrong, server was compromised, revoke the current certificate and issue a new one with a new key. Let's Encrypt allows you to do this. Certbot Certainly Force Renewal generates a new key and certificate. Certificate revocation. If your private key is compromised, contact your CA to revoke the certificate. Let's Encrypt supports OCSP, Online Certificate Status Protocol, for revocation checking. Browsers periodically check certificate revocation status. For a production application with multiple subdomains, emyap.com, www.emyap.com, api.emyap.com, admin.emyap.com, you need a certificate that covers all of them. Option 1 is separate certificates for each domain, simple but complex to manage. Jinx needs to serve the right certificate for each server_name. Each certificate renews independently. More certificates to monitor. Option 2, multi-domain certificate with SANs, one certificate, multiple domains listed in the subject, alternative names. Certbot can issue this. Certbot Jinx emyap.com www.emyap.com api.emyap.com. The D flag can be repeated for each domain. Option 3, wildcard certificate, star.myapp.com covers all immediate subdomains. One certificate for the entire domain. Requires DNS01 challenge, only way to validate wildcards. Certbot command with DNS challenge, Certbot Certainly DNS Cloudflare emyap.com dstar.myapp.com. The second dstar.myapp.com covers all subdomains, the first emyap.com covers the root. Trade-offs. Multi-domain SAN certificates require you to list every subdomain. If you add a new subdomain, reissue the certificate. Wildcard certificates cover all subdomains automatically but require DNS API access for the challenge. Let's Encrypt wildcards are valid for 90 days and require automated renewal via DNS01. The Jinx configuration for a wildcard certificate is the same as a single domain certificate in SSL_certificate. The difference is the certificate file itself covers more domains. Certbot Jinx integration. Certbot Jinx automatically configures Jinx, adding the SSL_certificate and SSL_certificate_key directives. This is the easiest path for initial setup. Certificates sometimes need to be revoked before their natural expiry if the private key is compromised, if the certificate was issued in error, or if you're changing your setup significantly. When to revoke: the private key was leaked, committed to Git, server was compromised, you're migrating away from a domain permanently and want to ensure old certificates can't be misused, the certificate has the wrong information. When not to revoke: certificate renewal time, just let Certbot renew, the new certificate automatically supersedes the old one. You're changing servers, the certificate follows the domain, not the server. Copy your certificate files to the new server. How to revoke a Let's Encrypt certificate. Certbot revoke certpath /etc /let'sencrypt /live myapp.com cert.pem reason key compromise. The reason flag accepts, unspecified, key compromise, affiliation changed, superseded, cessation of operation. After revocation, browsers check certificate revocation status using OCSP, Online Certificate Status Protocol. Most browsers use a stapled OCSP response from the server or make online requests. Revocation checking is imperfect, not all clients check, and some cache revocation status. Reissuing a certificate, after revoking, issue a new one. Certbot certainly force renewal dmyap.com. This generates a new private key and certificate. Update your Nginx configuration if the certificate path changed. OCSP stapling. You can configure Nginx to staple the OCSP response to the TLS handshake, saving clients from making a separate request to check revocation. This improves both performance and privacy. Add to your HTTPS server block, SSL_stapling on, SSL_stapling_verify on. A scenario about certificate file selection. You're configuring Nginx for HTTPS. Let's Encrypt issued your certificate and placed 4 files in /etc/let's encrypt /live /myapp.com /cert.pem, chain.pem, fullchain.pem, and privkey.pem. Your Nginx configuration has these 2 directives, SSL_certificate /etc/let's encrypt /live /myapp.com /cert.pem, SSL_certificate_key /etc/let's encrypt /live /myapp.com /privkey.pem. HTTPS works on Chrome on your laptop. But users report intermittent certificate not trusted errors on mobile devices, older Android browsers, and curl. What's the issue? Option A to privkey.pem is the wrong file. You should use chain.pem for SSL_certificate_key. The private key must be privkey.pem. Chain.pem contains CA certificates, not your private key. Option B, cert.pem only contains your domain certificate, not the full chain. Older clients and mobile devices can't verify the certificate because they don't have the intermediate CA certificate needed to build the trust chain. Use fullchain.pem instead. This is the correct diagnosis. Option C, the certificate needs to be renewed. Let's Encrypt certificates don't work on mobile. Let's Encrypt certificates are trusted on all major platforms. This is wrong. Option D, you need a paid commercial certificate for mobile compatibility. Also wrong, Let's Encrypt is trusted on all major platforms. The answer is B. Cert.pem lacks the intermediate CA certificates. Modern desktop Chrome has mechanisms to fetch missing intermediates, AIA fetching, so it works on your laptop. But many mobile browsers and curl don't do this. Always use fullchain.pem for SSL_certificate. It includes your certificate plus the full chain needed for all clients to verify trust.